Okay, so good morning. So today's topic is size reduction operation or comminution. So this is most important operation in mechanical operation for chemical engineering. Size reduction operation, size reduction operation means size reduction of the solid material. So particle size is playing a vital role in every process, chemical process industry. So that's why we have to be very much careful about for preparing the feed material when the feed material is used as the solid. So size reduction operation, that's why playing a vital role in chemical engineering operations. So size reduction means the large particles are converted into smaller particles. The process is also called as comminution. So it depends on the how much we are putting the thrust on it. So whether vertical or it is angular or twisting operation. So depending on the mode of operation, you will be able to get your desired particle size. So generally the methods for size reduction operation either by compression or by impact or by attrition or rubbing or cutting or shearing. Compression means this is some gripping should be there. Then after gripping the material, the compression will be developed. So work done by both surfaces. By the compression means by which means we are giving the compression. So work done by both the surfaces. Feed material that should be very much coarse material or abrasive material or non-sticky material because material characteristics also playing a vital role in such a size reduction process. And generally product relatively coarser, for example, just like a nut crusher. So in that case of nut crushing machine, the compression is mainly playing a vital role for it. Another one cause is the impact. Is also a fruitful cause for size reduction process. So generally impact how it is given by means of hathora, isn't it? So this kind of impact is there. So striking or collision of one body to another moving body, or the gravity impact or the dynamic impact. So these are the different way of putting the impact on the material to be crushed. Feed material, it may be brittle, it may be hard, it may be abrasive, it may be high moisture content because moisture content is a parameter which is playing a good role for size reduction operation. Product also we do expect our desired size of product that may be fine, that may be intermediate, that may be coarser. Hammer is the example that I means for impact size reduction. Another one is attrition or rubbing effect. Attrition means rubbing effect. Rubbing effect. So friction. Friction is generally given for size reduction process. That is the sliding or scrubbing, rolling of material. And in that case, particularly we used to give the material which is to be reduced in size, that is generally it is soft material or non-abrasive material. Product is generally product we do expect the fine material. File is the device, filing that we know it is very common to everybody, the filing material. So cutting and shearing, cutting in mainly it is applicable for the soft material which is generally cut into small pieces. Scissor is one of the devices. Criteria for comminution, size reduction process, what would be the criteria? That is the performance parameter if we consider the capacity, the energy equipment, the yield, and ideal comminution equipment that is high capacity, small energy requirement per unit product, yield of product of single size or size distribution. Performance evaluation is generally being done by ideal operation is taken as standard. Compare the actual with existing one and not feasible for crushing or grinding because of large deviation. Because energy is the main parameter here. Because in every size reduction operation, high energy input is required, and out of which a small energy portion is utilized for its size reduction, and the major portion of the input energy is utilized to overcome the friction. So that is the truth actually. So that's why the size reduction operation is highly energy intensive, because cost of power is there. Cost of power and energy is a major expense, and that's why you have to find out a suitable mechanism. That mechanism involved in size reduction, mainly material feed is distorted or strained, energy is sorted as mechanical energy or stress, additional force beyond ultimate strength, fracture occur, new surface generated. Because size reduction is operation is mainly, our objective is to get the small size of particles, smaller size of particles, smaller size of solid. So in parallelly with the production of smaller size, the surface area is created. So generally the power input is always compared with how much new surface area is created. Crushing efficiency, generally it is evaluated output by input. Output means how much energy output in the form of new surface energy to the how much energy input is there. That is the main formula for getting the crushing efficiency. The crushing efficiency is the ratio of surface energy created by crushing to the energy absorbed by the material. So, if suppose ES is the surface energy created per unit area, and delta AW is the specific surface that is created by the size reduction process per unit mass, and Wn the mechanical energy absorbed per unit mass of material, then one correlation is generally being used for finding out that Wn, that is mechanical energy absorbed per unit mass, is equal to Es into AWB minus AWA. AWA means uh, how much new surface area get. This delta is actually AWB minus AWA is the new surface area created. So as ES is much less than WN, so efficiency always we are getting less than 1. That is true, that I have already mentioned, that efficiency for size reduction operation is always less. And mechanical efficiency, if we consider that mechanical efficiency means the energy absorbed by the solid to the energy supplied to machine. How much energy is supplied to the machine and how much energy is absorbed by the solid. So that is being correlated with this equation, that is W is equal to Wn by nu m. Wn we have earlier we have seen that is into a Wb minus a Wa, and nu m is nu m into Uc, where W is energy supplied to the machine. Power requirement, how much power is required to run this machine? That is very vital. So how can you guess? Or how much power we can give for running this machine? So if suppose M is the feeding rate of the material, and then P is equal to M into W, that is M means the mass flow rate. So that the P will be W into M dot this mass flow rate. So that can be correlated with the equation that we know, the M dot, and W we are already we got the correlation ES into AWB minus AWA by nu C into nu M. So the P, that the power equipment, power requirement, that will be 6 m dot ES by NC mu C rho P into 1 by psi B. Psi B is the sphericity of the material B and sphericity of the material A. That is how much, what material is produced, its sphericity, and what feed was given and its sphericity. That can be correlated for getting the power requirement. Laws of size reduction. So what kind of laws are there for the size reduction process? It is absolutely based on the energy. based on the energy, how much energy is required for the size reduction and how much new energy, new surface energy is created. That correlation is generally discussed in three major size reduction law. The first law was the Rittinger's law. Rittinger's law was developed in 1867, and it states that work required to cross a given amount of material is proportional to new surface area created. So increase in specific surface. So the correlation is P by M. P is the power input by mass flow rate, means the power input per unit mass flow rate of field. That will be equal to Kr into 1 minus d bar SB minus 1 by dSA. That is, d is the diameter of the average diameter, that is actually shorter diameter of the particle. So that Kr is a constant which is called the Rittinger's constant. So this correlation is generally utilized for calculating the power input. But here in the Rittinger's law, some limitation is there in Rittinger's law, where the reduction ratio very high. In those cases, Rittinger's law is not being applicable. What is size? What is the reduction ratio? Reduction ratio means the size of the product by size of the field. That reduction ratio, if that reduction ratio is very high, in that case, Rittinger's law has some limitation to account. So that's why the next law was developed, that is Kick's law. Kick's law is the work required for crushing a given amount of material is constant for same reduction ratio. Here actually the reduction ratio is considered. So for any kind of solid material, if we keep the value of reduction ratio is fixed, then it can be correlated by the Kick's law. The work required for crushing a given amount of material is constant for some same reduction ratio. So if any size reduction for process for any solid material, if the size reduction ratio is fixed, then we can consider the amount of energy required, that should be almost equal. But here also some limitation is there. It is also not applicable for a broad range of reduction ratio. Only a certain range of reduction ratio, this Kick's law is applicable. Actually, it cannot explain for the higher size reduction ratio operation. So finally another one law came, that is the Bond's law, that work required to form particle of size dp from very large field is proportional to the square root of the surface to volume ratio of the product. So P, the power required, that is M, mass flow rate, that will be Kb. Kb is the constant which is called Bond constant, and by square root of dp, that is the particle size, that is from a particle size dp from very high large field. So dp basically the product diameter. So here one concept was developed, that is called work index. So a gross energy required in kilowatt hour per ton of field needed to reduce very large field to such a size that 80% of the product passes through 100 micrometer screen. Here one range has been established. Means we are going to apply the formula for a particular size range of product, and that for that case Kb, that value of the bond constant, that will be utilized by the experimental data. So one correlation was established where the product size range was given, that the 80% of the product will pass through the 100 micrometer screen. Feed size, it may be the large feed, but the product size will be the 100 micrometers. It will pass through 80% of the product will pass through 100 micrometer feed. That means we can consider that the average size of the product will be 100 micrometer. So if 80% of feed passes through from a mesh size dpa, and 80% of the product of mesh size DPB, then this kV can be utilized for calculating the power requirement, that is P by M is equal to 0.3162 W1 into 1 by. So W1 is the work index. That is work index. That work index is applicable for different material. It value will be different for different materials. So the thing is becoming easier to calculate the power input. So differential from the law. So if we consider these three laws, that is Kick's law, Dittinger's law, and Bond's law. So equal to considering these three laws, the generalized formula has been developed, that is the generalized differential equation for given cases, that is dP by M is equal to K into dds and dt to the ds to the power n. So where this n value varies for different equation. For if we apply the Kick's law, then putting the value of n is equal to 1, then it is possible to get the power input. So if n is considered 2, then the Dittinger's law is applicable there. And for Bond's law, the value of 1.5. So you can see almost 1 and 2. So if average of these two is 1.5. So Bond's law is, that's why, widely accepted. Size reduction equipment. So what kind of equipments are generally used in industry for size reduction process? Because if we consider the size reduction operation, size reduction process, so we will see a very big size of feed material, and ultimately we need to get the product size of very small, very fine. So in that case, a single operation is not sufficient. We have to adopt the multiple operations. So multiple size reduction machines we have to adopt. So accordingly, the first at the beginning, we need to have one suitable crusher. Then after crushing the material which is coming out from the crushing unit, then they will be used as feed for the grinding machine. And the product coming out from the grinding machine again can be used as the feed for the further grinding machine, which is ultra fine grinder, by which we can be able to get very fine as the final product. So first is crusher, then grinder, then ultra fine grinder. For solid materials, hard solid materials, this will be the sequence for utilizing the size reduction operations. So different types of crushers are there and popularly used in industry: jaw crusher, gyratory crushers, crushing rolls. So again there is a classification of crusher: primary crusher, secondary crusher. Primary crusher means when the feed material, feed size is very high, then the primary crusher at the beginning, at the first, primary crusher is utilized. Then if it is required to use a secondary crusher next. Otherwise, we can use directly to a suitable grinder. So depending on the size range of the feed and product, that is size reduction ratio. So the different reduction ratio are being applied for a different size reduction machine. In case of crushing operation, the size reduction is comparatively less. In case of grinder operation, the reduction ratio will be high. And in ultra fine grinder, the highest reduction ratio we can achieve. And cutting machine, that cutting machine is mostly applied for the soft material. Crushers are split crusher, slow speed crusher, coarse reduction, large quantities of solid. The main types are jaw crusher, gyratory crusher, smooth roll crusher, tooth roll crusher. These are the popular examples of primary crusher mainly. The first three operates by compression, and tooth roll crusher tear the feed material. A tooth roll crusher is mainly utilized for soft material, not very hard material. Jaw crusher, one jaw is there. Jaw is there just like this. The jaw is there. This jaw is driven by means of a electrical motor, and the material is fed. This is the nib gap through which the material is fed, which is to be crushed. And by the action of this jaw is executed by a pitment toggle system. Pitment toggle arrangement is there. By the arrangement of pitment toggle, this is executed. The movable jaw is operated and it is executed, and by the action of this movable jaw, this is the fixed jaw, this is fixed jaw, this is movable jaw. Feed material is given in this nib gap and it is executed, it is operated by means of electrical motor and a pitment toggle arrangement. So by the thrust of this, the material is crushed and the crushed material is come out from the bottom. Gyratory crusher is a crushing head is there. You see, this one is a crushing head. This crushing head, this is tapered. This design is tapered. Crushing head. Okay, the material is fed. Material to be crushed is fed from the top. There is a gap between the wall and the head, and this gyratory head is rotated in a gyratory motion. In a gyratory motion, they are rotating. So by the friction is created, friction is generated when the material is trying to pass through this gap. So by the action of this gyratory motion head, the material will be further crushed, and the crushed material will come out from this gap. This is crushing rolls. Crushing rolls mean two rolls are there. Two roller is there, and two roller, one is rotating clockwise, the another one is rotating anti-clockwise. Actually, it is two types. One type you may keep one roller fixed, another roller is rotating. So the front roller is, say this is front roller, so front roller is rotating in the anti-clockwise and the rear roller is kept fixed. So material is to be fed in this nib gap. So by the action of rotating roller, the material will be crushed and it will come down. But in other crushing rolls where both the rollers are rotating, so one is the rear roller is rotating in clockwise and the front roller is rotating anti-clockwise. So what will happen? Not only that, the roller speed RPM, that RPM is kept uneven. Means if both the rollers are rotating of different RPM, so that the shearing action will be generated. More shearing action will be generated, and that will be more useful and more fruitful in the crushing operation. Tooth roll crusher, you might have seen in the roadside also, where the sugar cane is crushed by means of this kind of tooth roll crusher. Two rolls are there, but that is tooth roll. This is not the smooth roll. So that sugar cane, this is soft material, so the acceptance of the sugar cane will be better if the surface is made smooth. Next, come to the grinding operation. The term grinder describes a variety of size reduction. Grinder means it is next to the crushing unit. Hammer mill is one of the example. Sometimes hammer mill is also called as secondary crusher, So hammer mill actually comes under the grinding operation, but sometimes it is also come into the also take as the secondary crusher also. So hammer mill means one hammer mill. This is a rotating disc where the hammers are attached with it. In some cases, it is loosely attached. In some cases, it is tightly attached. So this wheel, when this wheel is rotating under high speed, and the feed material is coming from the top, then under the action of this hammer, because it is rotating, so the material will be grinded, and after grinding, the grinded material will come down through the perforation of the case. Impact, by the action of impact, this is called, when this is tightly held, this is actually called the impact. Next is the rolling compression machine. This is another where the rollings, it is rolling, the crushing head is rolling. This is actually the different design of the crushing unit. Attrition mill, that is attrition, attrition, where rubbing, only rubbing action is there. Only rubbing action is there, isn't it? So in the village front, you might have seen there the home lady, they are actually grinding. They are grinding the that is soft material. That is soft material, either seeds or some material. They are generally giving grinded. They are grinded. So one piece is kept stationary. The upper piece is kept rotating by means of a driver. It is rotated. It is rotated by its hand, isn't it? And after crushing, the material is coming out to the periphery of that mill. So this is kind of attrition mill. It's the industrial version is there. This is this one. Tumbling mill means tumbling action. Tumbling action is there. One grinded media is there. That grinded media is put into the drum. When drum is rotating with RPM, the grinding media will also rotating. It is tumbling action, and by the collision of that grinding media, the material inside that is to be grinded further. Ball mill, tube mill, these are the most popular example of the grinding operation. Capacity and power requirement in tumbling mill, that is the most important one and the best predicted by computer simulation based on the experience. And the ultrafine grinder, where we need to have very fine particles, very fine material. This is called the ultrafine grinders, where there is a closed system, tubular system, and very high speed by air or gas. The high speed blow of air or gas, the material will be traveling through the tube, angular tube. So when during the journey of that material to be grinded, it will be colliding each other and also colliding with the wall. So ultimately, we will get very fine particles, very fine particles. That's why it is called the ultrafine grinder. So this one is the picture of fluid energy mill. Agitated mill, also agitated means agitated, sometimes used for getting the finer particles. Also agitated mill is also considered as a ultrafine grinder. Colloid mill is another one example for it. Cutting machine, knife cutter, cutting machine is mostly it is utilized for the softer material. So whatever the operation it is, the operation may be operated either in closed circuit operation or open circuit operation. Open circuit operation means the mill is there, feed is given, product is coming out. But in the product, it is not, you cannot ensure that the 100% product will be as per your desired level. So some oversized material will be there, some undersized material will be there. So if you need a particular size of material range, then you have to separate again. But in closed circuit operation, that separated material means the oversized material, which is oversized. That oversized material will be again recycled back to the feed zone so that it will be further crushed or grinded. So this is closed circuit operation is most common and this is most popular one. Feed control is another one parameter for this size reduction operation, feeding, discharge, and another one is the moisture content of the material to be classed. Solid material, obviously, the dry material will be more effectively reduced, but it has been observed that keeping a very small amount, 1 to 2% moisture in the feed material, that will help us in a better way. That will be profitable also, because during size reduction operation there is a chance of material spillage. So having that 1% or 2% moisture into it, the spillage of material can be effectively prevented. Energy consumption, as I know that energy consumption is the most important, because whenever the size reduction operation is executed, you have to be very much careful about how much energy input is there and how much energy is utilized for size reduction. So that the energy efficiency is a big parameter for every size reduction operation. Okay, so today up to now, next day we will discuss and we will take some numerical example. Thank you.